Next, we want to look at some of the basic graphs of the trig functions. Our first one is y equal cosine x. Written over here, graph y equal cosine x, and I thought we'd make a little table to begin with where x is in increments of pi over 4, and then we'll write the corresponding values of y equal cosine x. I know when x is equal to 0 that cosine of 0 is 1. When x is equal to pi over 4, which is 45 degrees, cosine of x is going to be equal to 1 over square root 2, which is about 0.7. When x is equal to pi over 2, cosine of pi over 2 is going to be 0. When x is 3 pi over 4, I know I'm in quadrant 3. The reference angle is pi over 4, so I know I'm going to get my 0.7. And then since I'm in quadrant, did I say 3? I mean quadrant 2, I know cosine is negative there, so negative 0.7. At pi, cosine of pi is going to be negative 1. Cosine of 5 pi over 4 is going to be negative 0.7. Cosine of 3 pi over 2 will be back to 0. Cosine of 7 pi over 4, 7 pi over 4 is in quadrant 4. Its reference angle is pi over 4, so the cosine is going to be 0.7, and in quadrant 4, cosine is positive, so it's positive 0.7. And then, of course, cosine of 2 pi is going to be back to 1. So I'm going to graph these ordered pairs. X equals 0, y equal 1. That's right here. X equal pi over 4, y equal 0.7. So here's pi over 2. Halfway to there is pi over 4. And so I'm going to say this is about 0.7 right here. At pi over 2, y is down to 0. At 3 pi over 4, which is right here, I'm down to negative 0.7. At pi, I go out to negative 1. Then back to negative 0.7, up to 0. At 7 pi over 4, y is equal to 0.7 again. And then at 2 pi, y is equal to 1. So if I connect these points with a nice smooth curve, I get one complete cycle of y equal cosine x. Now, the amplitude of this graph is how high or how low the graph goes. It's halfway between the highest point and the lowest point. This graph has an amplitude of 1. And then the time it takes for it to go, the length it takes for it to go through one complete cycle of all the values of y it's going to take on the x-axis, that's called the period of this graph. So this graph has a period of 2 pi. So this is my basic y equal cosine x graph. If I want to extend beyond 2 pi, I know I've gone from 0 to 2 pi for x. As I go farther on here, I'm just talking about angles that are coterminal with my original one, so I'm going to sketch out the same basic shape in both directions. I'll just keep continuing to put one complete cycle down. Now let's look at our second problem. Second problem, we're asking find x if cosine x is negative 1 over square root 2 and x is between 0 and 2 pi. So what I'm saying is that the cosine of x is negative 1 over square root 2, or negative 0.7, and x is between 0 and 2 pi. Well, if I go over to the graph, to about 0.7 on the graph, negative 0.7, which is negative 1 over square root 2, and then I'll just travel along the graph in a straight line and see where my straight line intersects that graph. It intersects right here, which is going to be x equal 3 pi over 4, and it intersects right here, which is x equal to 5 pi over 4. So cosine of 3 pi over 4 and cosine of 5 pi over 4 are both negative 1 over square root 2, and those are the only two values of x between 0 and 2 pi that's true for. So here's my answer to that question, 3 pi over 4 and 5 pi over 4. So once we have the graph of y equal cosine x, we can use the graph to find some values of x given certain values of cosine x. Let's look at another problem. It says give the amplitude and period, and I've got a graph that looks like this. Okay, so that goes through one complete cycle. It's a sine curve. It has an amplitude of 3. That is the average or halfway between the highest point and the lowest point. That's a total of 6. Half of that is 3, or it's just the height of that hill and the depth of that valley. So the amplitude for this graph is equal to 3, and then the period is the distance on the x-axis it takes to go through one complete cycle, where here is a length of pi over 4 and another 3 pi over 4, so 3 pi over 4 plus another pi over 4, that gives me 4 pi over 4, or pi. So that graph has a period of pi and an amplitude of 3. I'm going to walk over to the board now and work another problem. Here we have graph y equals 6 sine x, and I notice this coefficient 6 is going to change the amplitude of this graph from the graph of y equals sine x. So I'm going to begin by just sketching the graph real quickly of y equals sine x. I know when x is 0, sine x is 0. When x is pi over 2, the sine of x is 1. When x is pi, sine x is 0. 3 pi over 2, sine x is negative 1. I'll put that right there. And then back up to 0. So a quick sketch of y equals sine x will look like this. Now I'm just using that for reference because when I look at this equation, I see that this coefficient 6 is going to change each value of y from this equation. So where here I have y is equal to the sine of x, this is going to be y equals 6 times the sine of x. So where this red graph is 0, 6 times 0 will still be 0. When I get out to x equal pi over 2, I see that y is equal to 1 here on this graph, so y is going to be equal to 6 times that on this graph. So when y is 1 here, y is going to be equal to 6 over here. Now I drop back down to y equals 0, and 6 times 0 is 0. When x is equal to 3 pi over 2, y is equal to negative 1. 6 times negative 1 is negative 6, so that'll be down here. So if I multiply each of these values of y by 6, I'll get a graph that looks like this. This is just a quick, rough sketch of that graph. So you can see y equals sine x has an amplitude of 1. It looks like this. When I multiply each value of y by 6, I get a graph that looks like this, and I say this is a sine curve with an amplitude of 6. Okay, I want to work another problem. Problem 5, I have y is equal to 1/2 cosecant x. And notice that I've graphed here in green the graph of y equals sine x. It goes from 0 up to 1 when x is pi over 2, back down to 0, then down to negative 1 when x is 3 pi over 2, and then out to 2 pi. Now what's in red is the graph of its reciprocal, or y is equal to cosecant. Oops, let me get that right. Cosecant x. That's what I have in red, and that's the reciprocal values of y that you see here on the green graph. When x is equal to pi over 2, sine x is 1, the reciprocal of that is 1. So over here for this graph, when x is equal to 30 degrees, y is equal to 1/2, and so its reciprocal is going to be 2. Now the graph I'm looking for is the graph of 1/2 cosecant. So that's going to be a graph that has y values that are 1/2 of all these y values. So if I just look at my red graph here, and I take 1/2 of all these y values, I'll have the graph of 1/2 cosecant. So when y is equal to 1 right here, half of that is going to be 1/2. When y is equal to 2 up here, half of that is going to be 1. I'll have that. And when y is equal to 2 up here, half of that is going to be 1. And the higher up I go, half of each of those things is going to drop it down a little bit. So if I sketch this graph that looks like this, these y values are all approximately 1/2 of these y values right here. So I can get the graph of y equal 1/2 cosecant by first graphing my cosecant curve and then taking 1/2 of all those y values. Let's look at this part of the graph here. I'll use the same idea. When y is equal to negative 1, half of that is negative 1/2. When y is equal to 2, half of that is, when y is equal to negative 2, half of that is negative 1. And over here, when y is equal to 2, half of that is, again, negative 2, half of that is negative 1. So here, this part of the graph is going to look like this. So what's nice about graphing this way is that we have a basic graph right here, and we look at this coefficient, and we know how it affects the graph. It saves us from making a table. If we know what y equal cosecant looks like, then we certainly know what y equal 1/2 cosecant looks like. So a quick look at some graphing of the basic trig functions plus some amplitude.